Hello, Wayland Middle School. Mr. Farley here to give you a little video here on determining whether a relation is a function or not. And we're going to be looking specifically when the information is given to us in a table form and as ordered pairs. So let's get this going. We're going to start the video. Hopefully it's a good one. As you know, it is definitely an award-winning video. And let's get it going. So right now I have three different tables here, table A, B, and C. These are all known as relations, okay? So each one of these is its own relation. And what we are going to try to do is we're going to try to determine if the relation in each of these tables is a function or not. And the way that we can do that is by realizing a couple different pieces. One is the input here, this left column of each of the tables. These are your x's, okay? So the input in each of these table would be known as x, and you should be taking notes as we go, and you can just put little x's above the input table. Other thing to realize is the output are your y's, okay? So this table is just an xy table, the x coordinate and then the y coordinate. So what we want to try to do is look at the information in the table and see if this relation is indeed a function. And the way we do that is look at your inputs and ask yourself the question, do each of these inputs have an output? And they need to have one output only. So if you look at it, the input of 0 has an output of 5. It only has one output, and that one output is 5. All right, let's try 1. The input of 1 has only one output, which is 6. That's a good thing. This is leading us to see what a function is. The input of 2 has only one output, which is 7. The input of 3 only has one output, which is 8. And the input of 4 has one output, which is 9. This is definitely a function. So letter A is a function. All right. So this one is a function. All right. Yay. All right. Let's look at B. So we're going to still check the inputs. We only care about the inputs. Do the inputs have one output? Okay. So let's say input of 2. The input of 2 has an output of 2. That's fine. That looks good. The input of 4 has also an output of 2. Believe it or not, this is okay because the input of 4 only has one unique output, and that output is 2. Here, 6 has an input, the output is 2. That's okay. Input of 8, output of 2. That's okay. And an input of 10, output of 2. This also, table B is a function. Okay, so we have a function for A, and now we have a function for B. When I look at C, this is where we're going to realize it is not a function. And the reason for it is we'll go through all of the inputs again. Input of 5 has an output of 1. That's okay. That's a good thing. The input of 6 has an output of 2, and the input of 6 has an output of 3. This situation right here leads this relation to not being a function. And additionally, if you look down here, input of 7 has an output of 4, and the input of 7 has an output of 5. So this is telling us the input of 7 has two different outputs. This is what prevents it from being a function. This is not a function for these two reasons. Okay, the 6s have two outputs and the 7s have two outputs. So a really fast way to see if whether or not this is a function or not is just look at the inputs and kind of ask yourself, do the inputs repeat at all? 0, 1, 2, 3, and 4, they don't repeat. There's not any number that repeats as an input. That brings us to a function. Looking at B, 2, 4, 6, 8, 10, nothing repeats in the X. that leads us to this relation being a function. And finally, this one here, we have a little problem. All right, the 6's repeat and the 7's repeat. That's what tells us this is not a function. So very similarly, we were able to look down below here and answer the second question. Is either list of the ordered pairs a function? Please remember, ordered pairs is x comma y. All right, so all the way, I have my x is first, my y is second. X is first, y is second, all the way through. And you can ask yourself the same question. Looking at this, do any of the x's repeat? I see an x of 2, 4, 3, 6, and 2. Uh-oh. The input of 2 happens twice here with these ordered pairs. That tells us this is not a function. All right, because it's telling us the input of 2 has an output of -3, and the input of 2 has an output of +3. Two different outputs for that one input. That makes it not a function. Last one, let's check it out. Again, XYs. You can write these right in your notes. XY, 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 all the way through. And as I'm doing that, I'm trying to think right now, looking at my inputs, my Ys. My inputs, my X's, do they repeat? I see a -2, a -1, 0, 1, and 2. None of those inputs repeat. That means that second one is an example of a function. So there you have it. That is our video, lesson 1. Is it a function? Looking at tables and ordered pairs. As usual, if you have any questions, please check in with Mr. Coton, Mr. Robinette, or myself, and we'll be happy to help you through it all. Take care, everyone.